Section 5.1, Basic Concepts of Probability, Video 8. There's two types of probabilities that we've been dealing with, theoretical and empirical. Theoretical probability is when you have an experiment, but all of the outcomes are equally likely, meaning that they have the same chance of occurring, such as flipping a coin, heads or tails, they're both equally likely. Drawing a card from a deck of cards, assuming that they're randomly shuffled, every card has the same chance of being selected. Or putting the 8 letters of the word Arkansas in a bag and then drawing one of them at random. All of them are equally likely. But if the outcomes for an experiment are equally likely, then you can calculate the probability of an event by simply comparing two numbers. In fact, it's exactly what we did when we did the probability model for drawing a letter from the word Arkansas. You just make a fraction. On the numerator of the fraction is the number of outcomes in event E. Remember, an event is just a collection of outcomes. When we selected a letter from the word Arkansas, the event you drew a letter A had 3 outcomes because there were 3 A's in Arkansas. What do you think the denominator would be? Well, on the Arkansas problem, all the denominators were 8 because there were 8 total letters in Arkansas. The letters collectively represented the sample space. So generically, the denominator of a probability is the number of outcomes in the sample space. Number of outcomes in the sample space. Running out of room here, but I'll make it work. So for example, let's say you draw a card from a standard deck of 52 cards. And let's let D be the event that you draw a diamond. What's the probability of drawing a diamond? Well, all we have to do is count the number of diamonds and compare it to the number of cards. Because the deck of cards represents the entire sample space. Well, we've already said multiple times that there are 52 cards in a deck. But how many diamonds are there? Well, you can count them. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So there were 13. Or you could have said there are 52 cards and there's 4 different suits. Each one shows up the same number of times, and done 52 divided by 4, which would have also given you 13. Before we turn this into a decimal, let's see if we can reduce this. You may or may not know that 52 is 13 times 4. If you're familiar with the deck of cards, it makes sense. There's 4 suits, 13 of each rank. 4 times 13 is 52. So I can reduce this by 13. Oh, warning. Warning. In the homework, if they ask you for a fraction answer, they are going to expect it to be reduced, in which case you should reduce it. However, if they ask you for a decimal or a percent, there's no need to reduce, just divide it in your calculator. This will reduce to 1/4, which makes perfect sense because 1/4 of the deck is diamonds. And of course, as a decimal, that's 0.25, and as a percent, that's 25%. So that's all theoretical probability is. Now, does this mean if I draw 4 cards, I will always get 1 diamond? 1 out of 4? No. That means in the long run, if I keep drawing cards over and over again, the percent of the times that I get a diamond will get closer and closer to 25%. Let's talk about the other type of probability.